Shubho Sandhya. Good evening, everyone. Department of Statistics entered in 60 years on 1st July 2020. This department, established by Professor Khandakar Monor Hossain, we are celebrating 60 years in Facebook Live program. Already, we broadcast 20 episodes. Today is the 21st episode. You all are welcome to this episode. Dear Facebook friends and viewers, I am Mohammad Monimul Haq, at present working in the Department of Statistics, and I take this opportunity to thank the Porisankhan Poribar and Department of Statistics for giving me the continuous support and encourage to arrange this series program. Today, I am very happy to inform you that Dr. Dulal K Bhaumik, Professor of Biostatistics, Psychiatry and Bioengineering, Director, Biostatistical Research Center, Director, Biostatistics PhD Program, University of Illinois at Chicago, USA, is our keynote speaker at the International Statistics webinar. I welcome Dr. Dulal K Bhaumik to this program. Dr. Bhaumik has worked in the field of psychiatry, neuroimaging, microbiome, and mental health. This has involved development and application of statistical methods in estimation, multiple comparisons, sample size determination for hierarchical longitudinal models, meta-analysis for rare events, analysis of microarray data. He has contributed to the development of statistical methodology and dissemination of software for analyzing multi-level models, traumatic brain injury, substance abuses. His work has been recognized by the American Statistical Association and Royal Statistical Society by electing him a fellow of the American Statistical Association and Royal Statistical Society, and by awarding him the Youden Award twice for interlaboratory testing. His recent research in microbiome has been covered by more than 30 national and international news channels in different languages. Dear viewers, the title of the statistics webinar is Statistical Methods for Measuring Agreement Involving Longitudinal Data. Dear viewers, আমাদের সাথে আরো বেশ কয়েকজন গেস্ট আছেন, তার মধ্যে আমি এখন আরো একজন গেস্টকে পরিচয় করিয়ে দিই। উনি আপনাদের সবার অতি পরিচিত প্রফেসর বিমল কে সিনহা। উনি সব সময় আমাদেরকে এনকারেজ করেন, উনি শোনার জন্য এসেছেন এবং উনি আজকে লেকচারটি শুনবেন। যেহেতু উনি ফেসবুক ব্যবহার করেন না, সেই জন্য উনি এই প্ল্যাটফর্মটি ব্যবহার করতে চেয়েছেন আর কি লেকচারটি শোনার জন্য। এবং আমি আরো একটি পরিচয় দিয়ে দিই, ডক্টর দুলাল কে ভৌমিক আসলে বিমল কে সিনহা এবং বিকাশ কে সিনহার ভাগ্নে, এবং একই পরিবার থেকে তিনজন নাম করা স্ট্যাটিস্টিশিয়ান। এটা আসলে মানে পৃথিবীর ইতিহাসে মনে হয় বিরল। তো আমরা আসলে ভাগ্যবান যে ওনাদের সবাইকেই আমরা আমাদের এই সিরিজ লেকচারে আনতে পেরেছি। আমি এখন ডক্টর দুলাল কে ভৌমিককে অনুরোধ করব তার লেকচারে যাওয়ার জন্য। তার আগে ভিউয়ার্স, আপনারা যারা এই লেকচারটি শুনছেন তারা এই প্রোগ্রামটি পুরোটি শুনবেন, এবং স্পেশালি যারা রিসার্চের সাথে জড়িত আছেন তারা আসলে অনেক লাইন পাবেন এখান থেকে। সেই সাথে আপনারা আপনাদের মতামত জানাতে পারেন কমেন্টের মাধ্যমে, বা আপনাদের প্রশ্নগুলো কমেন্টের মাধ্যমে করে রাখবেন। আমরা এই প্রোগ্রামের শেষে আপনাদের সেই প্রশ্নগুলিকে আমাদের যিনি কিনোট স্পিকার আছেন ডক্টর দুলাল কে ভৌমিক, উনি আপনাদের প্রশ্নগুলোর উত্তর দিবেন। এবং সেই সাথে বলে রাখি যে আপনারা যারা প্রশ্ন করবেন, আমি স্পেশালি স্টুডেন্টদেরকে অনুরোধ করছি যে আমাদের স্টুডেন্ট ভাইরা যারা এই প্রোগ্রামটি সরাসরি দেখছে তাদের কাছে অনুরোধ, তোমরা প্রশ্ন করো এবং প্রশ্ন করার পরে সরাসরি এই প্রোগ্রামে যুক্ত হয়ে স্যারের সাথে কথা বলার সুযোগ আমি করে দিব ইনশাআল্লাহ। তো আমরা শুরু করতে যাচ্ছি আজকের এই প্রোগ্রামটি। আমি অনুরোধ করছি ডক্টর দুলাল কে ভৌমিক আপনাকে আজকের এই লেকচার শুরু করার জন্য।
Thank you, Monimul. Thank you very much for organizing this conference or the talk, and I'm very happy to be present here. আমি কিছুটা বাংলা কিছুটা ইংরেজিতে কন্টিনিউ করব যখন মনে
জি
হচ্ছে
স্যার, একটু মিক্সড বলবেন। জি।
and I'm extremely happy to know that you are entering into the 60th birthday of the Department of Statistics at Rajshahi University, or probably Rajshahi University was born at that time. Now, the father of this department who established basically Monirul Islam, I think. I met him in 1997 when I went to your department to give a talk. He was there with his wife and Dr. Bashir Mi, I think he was the head of the department at that time. And we had a long chat, and he was I was very impressed talking with him, and I enjoyed during my stay over there. That was 1997. After a long time, then again I gave a talk to your department in 2018. That was probably February or something like that type thing. So this is my third talk to your department, and the month of July it was established. In this connection, I can remember that the person who basically brought statistics in the entire continent, and all of you have probably heard the name, Prashanto Mahalanobish, was also born in the 1st of July. So this is a kind of connection of Rajshahi University Statistics Department and Mahalanobish. Anyway, today's talk, as Monimul mentioned, that it will be on agreement, disagreement, that type of thing. So before going to my slides, I would like to mention that I'm very, very happy to be present with all of you, though I cannot see many of you. And I really enjoyed when last time in 2018, I was in your department for the whole day. And I wish that those normal days will be coming back soon. And I'll be again present. I'll be again going to your department to see all of you. But at this moment, we have to be online. And that is the way it is working all over the world. And we are also here. So while the talk is going on, I'll not have any opportunity to see you, but at the end, after my talk is over, please feel free to ask me questions if you have, and I'll try to answer best to your questions. Now, just a joke kind of thing, that while this COVID lockdown is going on, I saw many of the Bangladeshi natoks during this time, and many of these dramas, I found that people are talking about going to Pabna and coming out of Pabna. Now, what is meant by that? Pabna is especially very, my house is there, not that far away from this university. It takes only about two hours. Now, in the natoks at least, Pabna, people go to Pabna because of mental health, and when somebody is coming out of Pabna, we have to understand what kind of person is that. And I'm in the mental health psychiatry department for a long time, about 20 years. My talk could have been on psychiatry, but this is a different talk. So next time, if I give any talk, and which I believe will be on mental health. Now, today's talk is based on one of my PhD students' dissertation. Her name is Rajshahi, and she completed, I think, either 18 or 19, 2018 or 19. And she was working at Veteran Affairs, and that is the ex-military medical center in USA. And now she has joined the FDA. So the entire talk is based on her dissertation and statistical methods for measuring agreement involving longitudinal data. So let's try to figure out what does it mean, that agreement. The agreement is not only in some particular area, but it has applications in many areas of science, many areas. So let me start with a very simple example. Suppose your teacher, Professor Monimul Haq, has given you a test, it's a statistical test on inference. And let me assume that there are 50 students in the class, and all of you took the exam. The students I want to mention took the exam, and so he has the exam copy. And now he's going to grade. He's going to grade your exams. So what I'm doing, before he grades, I made a copy. I made a copy of all of your exams, and then not only one copy, I made, say, 6 copies of your exam. Then those 6 copies of the exam are with me, and the original, the professor is going to grade it. Then I have 6 copies. After 6 months, I'm giving a fresh copy, the copy that I graded, and I took out his copy, what he graded. And then I'm asking again him that why don't you grade these exams? Now 6 months over, he forgot how he graded, what are the scores of the students, he completely forgot. Now he's grading freshly, and he's giving again scores. So the same exam, now I have 2 scores. One was right now, and the other one is 6 months later. And I'm doing the same thing, though he set up the exam and he was the main teacher for grading. But what I did, I gave 1 copy to some other statistics professor and asked him to grade. And he also graded. And then after 6 months, I'm also giving him this test and he's grading. So, and then the 3rd professor, I'm asking the same thing. So what happens? 3 professors grade your exam. How many times is professor graded? 2 times. So the question is that, are your scores almost the same from these 3 professors who graded? They should be the same because your exam didn't get changed. It remains the same exam. 3 people are grading. Well, there will be some kind of variation, I understand, but are they matching those gradings? If not, then what the score you are getting or the division you are getting, that absolutely makes no sense because it is very much subjective then. So these questions are coming repeatedly. Then again, another question. How many times I asked the professor to grade your exam? Twice. Now, these are called the within graders evaluation. Whether the teacher himself is agreeing with him in the sense that he graded twice. Are those 2 grades different? He completely forgot after 6 months what he graded. So he graded twice, and is he agreeing with himself or herself? And if not, then what is going on? So these questions are important not only in the field of education, but also in the huge field of medicine. And the example that I'll be showing, it is related to, okay, the slide, please. Hello, you. Let me continue. The example that I'll be showing is related to a medical field. This is basically the knee joint example. Means that there was that there are arthritis. Many people have problems with the knee joint, and they go for surgery. And after the surgery or before surgery, there will be some kind of, say, taking X-rays, and doctors would like to see how it is progressing over time. So they are calculating the knee joint, that kind of what is the width between the 2 joints, and that is our measurement. Now the slides, I didn't see the slides. Okay. Yeah, probably. So there are 3 radiologists who are evaluating these X-rays and 1 computer. So basically there are 3 evaluators, 2 human beings and 1 computer. And every doctor evaluated those X-rays twice, after 3 months, once, and then after 3 months. And the computer also evaluated after 2 months. Next slide, please. Yeah.
দুঃখিত ভিউয়ার্স, আমার কম্পিউটারটি রিস্টার্ট হয়ে গিয়েছিল যে কোনো কারণেই হোক। আমরা অনাকাঙ্ক্ষিত অসুবিধার জন্য দুঃখ প্রকাশ করছি। স্যার, আপনি কন্টিনিউ করেন, কোন স্লাইড থেকে শুরু করবেন?
The next slide, please.
Okay.
Okay. So the example that I started, that I just explained, it is the basically knee joint example. What is glucosamine and choroidine arthritis intervention trial? I'll be calling it GATE instead of the full name. It was conducted by VA, the Veteran Affairs of USA Hines, and it was funded by NIH to see, and that the clinical trial was placebo-controlled, parallel, double-blind, 5 randomized clinical trial. But anyway, the data that we have got is from this trial, and there are about 325 subjects involved in the trial, but only 29 subjects completed, or the complete data we got from only 29 subjects. As I explained, that it's basically measuring the joint space width, which is been denoted by JSW, from radiographs of knees affected by osteoarthritis, and we'll see that the data are collected, the duration of that was 2 years at the baseline, 1 year and 2 years. So 3 observations are there at the baseline, year 1 and year 2. And they are they are measuring basically the joint space width by 2 manual readers, call it radiologists, and a computer measurement system. So there are 3 evaluators, and would like to compare whether the measurements of the knee width we are getting longitudinally, means over time, from these 3 evaluators, whether those are agreeing with each other or not. So the problem is, please go to the next slide. Yeah, we can see that this is a patient which is standing, and you can see the knee, hatu, and taking the pictures of the x-rays, that is the black plate, you can see, and it is taking the x-ray of those knees for each of the patients. The total number of patients, as I mentioned, was a little bit more than 300, but we got 29 complete measures from the evaluators. So please go to the next. And the joint we can see, and we can see that there is a kind of gap. So that is the width we are measuring. In between, you see that in between there is a gap, there is a between those two, and we are measuring those joints. Okay, please, next slide. That is even better now, the width that we can see what is our measurement. Okay, please, the next slide. So true value is unknown. We don't know exactly what is the exact gap between those other joint measures, JSW, we don't know that. 2 manual measures of JSW are equal. That is, we are asking the question. And there are 2 evaluators, or who are taking the measurements. Are those 2 equal? 2 manual readings are the same as computer generated measurements. Now, one reason they brought computer is that everything is now automated, in the sense that probably human being measurements will be going away very soon, and will be totally depending on computer measurements or some artificial intelligence. But before replacing human, would like to see whether those machines, either computer or whatever the machines are there, whether they are agreeing with the human measures. If not, if there is a discrepancy, then probably it is not a good idea to replace by the machines. So that's why the computer is coming into picture. So first question is that if the computer measurements are different, then people will be asking that, well, computer is different, then you should not replace human beings. But at the same time, we can ask the same question, whether the human measurements are also the same or not. And if not, then what is wrong with the deviation of the computer? So we would like to compare not only the two humans, two manuals, but also with the computer, and whether computer is close to one evaluator, the first, or the computer is more close to the second evaluator. So basically, we'll be comparing evaluator human one, the manual one versus manual two, manual one versus computer, manual two versus computer, and all possible three comparisons will be there. Now, how do we evaluate agreement for all these raters? So there are basically three raters, and we'd like to see the agreement between raters and also within raters. Within raters means that every rater evaluated the same plate twice at every time point. In the baseline, the evaluator or the rater rated it twice. Year one rated it twice, and year two also rated twice. So question is that whether that is called the within rating, whether that is also consistent or not. So the problem is now huge, because not only the between raters comparison, but also within raters. And the problem will continue like that. But that is the motivation of this work. So let's go to the next slide, please. And there are literature, but what the literature is there, these are very recent literature. Now let me tell you the story of my involvement in this. It was around 20 to 22, that means 2002 or maybe 3. Dr. Sinha, the other Sinha, Vikas Sinha, who is in Calcutta, he was visiting UIC, the same department, not me, but some other professor, Dr. Hedayat. And Hedayat has a student, graduate student, at that time they are working on agreement. Probably I attended a talk, but I can't remember, and I was not interested at all at that time. But around, say, 2012 or 13, when this student of mine, Rajshahi, she came to me with this kind of data and wanted to know the agreement. By that time, I read a couple of papers, one from JASA, one from biometrics, and so on. And I thought that I had an opportunity to learn this subject, which I did not at that time. But this is a very good time to get involved into this area. So I started working with her, and Dr. Sinha, because Sinha was a committee member in her dissertation. So we got started. But the complexity of Hairung's dissertation, complexity of data of Hairung's dissertation is much more, in the sense that here I'm getting the longitudinal data, and not only that, I'm getting multiple measurements coming from the same rater at the same time. Means not only the longitudinal, but repeated measures, in the sense that those are independent repeated measures. Independent in the sense that the rater could not remember what he evaluated, except the fact that those are nested within the same rater. So we have to understand first the complexity of the problem. Not only the problem, the data complexity. Why the data is so complex? Because of two reasons. Because we have getting multiple measurements of the same rater is evaluating multiple plates, X-ray plates over the time, which is longitudinal, and at every plate has been evaluated by the rater, or rating the plate twice. So that is also repeated measures, and as a result, we are getting basically the scope of within rater agreement and also between rater agreement. So that is the complexity of the data evaluation. And we have to incorporate all this complexity when we are developing the model. So let's go to the next slide, please. Okay. Now, generally, in the past, with just only the categorical data, Cohen's kappa is being used. Cohen kappa doesn't take care of this longitudinal nature of the data or the repeated measurements, nothing like that. There are categories, and we can see that in this slide, there are two raters, X and Y, and there are T categories, and we look at the proportion that both rater X and Y, how many people put in category 1, and that proportion is P11, P12, and so on. And P1 dot is the proportion of the let me call it proportion from rater X who rated in category 1 all those subjects. And the Cohen's kappa measurement is P naught, basically P naught minus PE. P is the product probability under the assumption that those are independent. Anyway, those are the product of the marginal products. And Cohen's kappa is P naught minus PE, 1 minus P. Now the question is, this is not suitable for our data because, first of all, our data is not of category type. It is a continuous data. On the top of that, we have multiple observations or measures from the same rater. So where should we put? Then we have to make tables like that, many tables for every plate measuring and also over time and so on. And we'll have a huge number of tables and how to incorporate all those tables. So basically, this is not useful for our complex data. So let's go to the next one, please. And this is one example. This example is extremely very interesting. And I should say that if we look at the agreement is 0.002, which is very small. Basically, there is no agreement. Now, look at the agreement. The rater X and Y on category 2, they are mostly agreeing. There are 100 subjects, mostly agreeing, because out of 100, 80 of them in category 2. And 80 of them in category 2 means rater X is saying that this subject should go to the category 2, and rater Y also is saying that they should go to category 2. And 80 of them are agreeing out of 100. So we should expect that the agreement should be huge. But look at category 1. So the remaining 20, out of the 20, 80 of them agreed, both X and Y. The remaining 20, the category 1, they are not agreeing just only on one subject in category 1, that you can see. Only one out of 20. And where are the other 19? Those are the off diagonal. So if rater X say that category 1, rater Y is saying that no, it should be category 2, and that is 6. And rater X is saying it should be in category 2. On the other hand, rater Y is saying category 1. And those number of subjects is 13. So on 20 subjects, they could not agree. But on 80 subjects, they agreed. But when we are computing the kappa, the agreement, we are getting 0.002, which is basically saying that there is no agreement, which is not the case. And Cohen's kappa, unfortunate thing, is even today, most of the people who are applying this kind of agreement in other fields like sociology, psychology, mental health, psychiatry, what they are using? They are still using Cohen kappa. And what is the reason? Because it is easy to compute. They don't go involved into complex statistics, though it is correct. So our job is not only to develop something, but also to spread the news that the Cohen's kappa is not applicable for your complex data, and here is a solution. That is one reason of doing this work also. Now let's go to the next slide. Okay, so it will continue like that. And Dr. Sinha, because Sinha, they modified the original kappa. They gave a better solution for that. And that measurement we can see is kappa M1, the very bottom one, that is their contribution. Okay, the next one, please. And we can skip that. So basically, this is a plotting of our data, whether they are agreeing or not. Now, let's bring the Pearson's correlation coefficient and the drawbacks of that. That is the goal. What is the goal? The goal is to see the agreement. Now think about the linear regression, and we know that when all the points are on the line, or all the points, if I can draw a line passing through all the points, then the correlation will be, the slope, every point, there is no error, and so on and so on. But is that much useful in terms of agreement? Okay, one thing is clear. In the agreement, if I say, suppose I am a rater and there is other rater also, there are only two raters. The simple problem, there are two raters, and I am evaluating many subjects, and that rater are also evaluating those subjects. If I say that the score of this subject is 0, and if the other rater should also say that the score should be 0, when we are in perfect agreement. But that is not the case. Think about this, the dots. The dots are basically the data, the real data scatter plot. And the X guy is saying that the measurement is 0, whereas the Y guy, the very first dot close to the Y-axis, the Y guy is saying that he has a measure, whatever the measure is, not 0, but something else. But in a perfect agreement, that should not be the case. But if we draw, we can obviously pass through a line passing through all the points, all the dots, and then the correlation will be 1 because I don't see any error, and so on. So Pearson correlation is not doing a great job for this kind of thing, for this in the field of the agreement. It has a lacking. On the other hand, when there will be no lacking, if the line passes through all the points, passes through the 0, number 1, and it should also make an angle 45 degree. And these are all for continuous data, as you can see. Also, the line should be 45 degree. Why it should pass the point 0 origin? The reason is that for a perfect agreement, if I give a score 0 to a student, then other teacher also should give the same score 0. And not only that, that should be true for any student. If I gave him or her a score say 90, the other evaluator or rater also should give the score 90 for perfect agreement. And when there is a perfect agreement, then all the points will be there, and you can pass a line, and the line should be passing through the origin, making an angle 45 degree. But Pearson or the perfect linear regression doesn't address that problem, and there are different other situations also. So first we showed that Cohen's kappa is not appropriate for our problem to use the Cohen's kappa, that measurement. Then now we are showing that even that the whole concept of linear regression, Pearson correlation, and so on is not also applicable for our data. As a matter of fact, for any data, continuous data, that is not applicable. And our data is much more complex because it is repeated over time and repeated within the same time. So let's see what we can do. Next slide, please. Okay, it's basically the same concept is repeated, and I have given the reference biometrics paper, and if any one of you are interested, please go through that paper, or you can ask me for the paper. I'll mail you. So next slide, please. Okay, now let's look at Lean's. Actually, the measurement that I'm going to propose was developed by Lean for simple data, not that complex data, but very simple data. So he computed MSD, mean square deviation between the two raters, expected value, the difference square. And if you do that, the math will be mu y minus mu x, the difference of the two mean square, then the variance minus the two of the covariance. That is the thing. MSD is always positive because it is the expected value of a square. Not easy to interpret. Yeah, no easy way to set up a common allowance for MSD. Well, he has a measurement, but it is not that easy to interpret what is going on. One simple thing is that I'm measuring the difference of those two raters squaring. And so this is basically the expected value of the square of the difference. That's it. Other than that, I don't see that much over there. So next slide, please. Yeah, next slide, please. Okay. So anyway, based on that, MSD, no, slide before, please. Yeah, this one. So this is the most important thing for my talk, because this expression will be coming again and again. The measurement, what Lin defined as the concordance correlation coefficient. So concordance correlation coefficient is very different from Pearson correlation coefficient. Let's try to see the last expression. The last expression is 2 times the covariance divided by the variance square. I'm sorry, the variance of the first rater, variance of the second rater, plus the mean difference. Okay, now let's see how it is different exactly from the Pearson correlation. A huge difference. But Pearson correlation coefficient is getting involved with 2 things basically. One is the covariance and the other one is the variance or the variances. But here in this expression, we see that it is not only the second order moments, but also the first order moment, the difference of the means. The difference of the means is extremely important when you are computing the agreement, because if the mean is different, where we are hitting, where we are trying to get, if those are different, then we are basically staying away from the target. And the second order coefficients are basically measuring the variability of the data or the association of the data. So I can measure the association of the data. Let me give you an example. When the passing score is 60, and I would like to see that most of the students are passing, then I see that in a class I evaluated, the students are getting in between 50 and say 55 and 65. So I'm hitting the target because the students want to pass, and the variation is not that much also because everybody is surrounding at 60. But if students are getting the highest score of the class is 50, the lowest score of the class is 48. So all the students are surrounding basically 49, 48, something like that. In that case, what is happening? In that case, there is not that much variation, but students are deviating from the target. Their goal is to pass, and they are basically failing. So that kind of, compactness is not that important because they are away from the target. So we have to understand that when we are evaluating, it is not only the second order moments like the variances, but the first order moment or the mean, the deviation, whether those two means are close to each other, is also important, and they should come into picture while measuring the agreement. So the Lin's approach, I think it appeared maybe in 1983, around that time. His measurement, what is called the concordance correlation coefficient, is based on the mean, the variance, and the covariance. Now look at when the means are the same, that means mu y minus mu x, both of them are the same, at least the agreement mean y is the equal, then that portion will be going to 0. And when the x is equal to y, basically, then that 2 times covariance will be 2 times the variance, and the denominator will be also 2 times. So what is happening? The numerator and denominator will be cancelling with each other, and the value will be 1. So when the value is 1, when the measures, when the mean measure of the rater y is the same as the mean measure of rater x, and also their variances are equal, and so on, and in that case, this value of the concordance correlation will be 1. But this definition or the expression is based on a single set of data, not longitudinal, not repeated. No covariance is there, but only rater y measured all the students or the subjects only once, and rater x also measured all the subject only once. And in that case, we can define that. But for our complex data, we cannot do that. So we have to do something else. Let's go to the next step. Next slide, please. Okay, while going on, let's try to give the kind of overview of the next slides. So what we saw that Lin's definition is very good. Actually, his measure for agreement is extremely beautiful for continuous data, but we cannot do that. We cannot use it because our data has longitudinal effect. But basically, our data is a kind of vector type of data, and all these data points, when they are coming from the same subject or the same evaluator or rater, those are correlated. So you have to bring the matrix notation to define the concordance correlation. So we have to generalize Lin's expression in terms of matrix for the repeated measures, and that first we are going to do. And then we have to see that whatever we have defined, that is also meaningful. That means when the two raters are basically giving the same measures, that will be the value of the general value of that thing, of that concordance correlation should be either 1, or when they are completely opposite. And what is meant by opposite, we have to see that also. That should be -1, and the interpretation of 0 should be there. In other words, it should be bounded by -1 and +1. And for the perfect agreement, we should get the value 1. So that should be the general expression for that concordance correlation coefficient when we are generalizing that for matrix, for vector data. And remember, this vector data is obvious from our experiment, as every from every subject, a rater or evaluator is getting multiple observations, 2 observations at the same time, and 3 observations over the time. So 3 times 2 is 6 observations we do have, and all these 6 expected to be correlated because those are coming from the same subject, and also the evaluators are there measuring the same. So we have to take care of all those things. And in our model, first we have to define a model, and then once the model is defined, when the model is proposed, then use the model for the concordance correlation coefficient, how to do it. And that we are going to do. But it seems that Monimul is not getting the connection.
Let's see.
Is it coming? Not yet. I think while he's trying, let me give a few other examples of agreement. The first one I gave in the context of grading your exams. The second one in the context of gait problem, where they're measuring the knee joint, the gap between the two joints. That is the second measurement, what is called J joint, JSW. And there are many other examples also. We can think about what I work in groundwater. In groundwater, this is not a groundwater, but the water-related problem. Water-related problem, before drinking water or certifying the water that we are drinking, that, okay, this is good. So, Monimul, let's go to the next one. Okay, so as I mentioned, the CCC should be always between -1 and 1. The CCC is 0 only when sigma yx is 0. That means that covariance is 0. And when it is 1 or when it is -1, that I already explained. So let's go to the next slide, please. Now, before going to this kind of slides, there is a picture, there is a figure. So let's go to that figure, the next one. Figure will tell us better to understand the model. Okay, so this is a data structure. As I repeatedly said, that we should understand the data structure first, and it will help us to develop the model. Now we can see that the level 3, the top one, is coming from a subject. So subject is the level 3. Ooh. Okay, the subject is level 3. And this subject has been observed by a rater 3 times. 3 times means at the baseline, that is 1, then year 1, that is 2, and year 2, that is 3. So I have 3 measures. I have 3 measures over the time, and that is level 2. That means these years or times are nested within the subject. So the baseline X-ray, 1 year X-ray, and 2 year X-ray, that means those plates are nested within the subject. Now, let's go to the baseline X-ray. And baseline X-ray was being evaluated by a rater twice. And we are calling it reading 1, reading 2. Those are the replications we can think. Those are the observations we can think. So that is level 1. Level 1 is the very bottom one. That means we are evaluating an X-ray twice. But how this X-ray is coming? They are coming from year 1 or baseline or year 2. That is level 2. How did you get these X-rays? Those are coming from the subject, and that is level 3. So in a mixed effects model, we can think that it is a third level model, hierarchy model. This is called the hierarchy, having 3 levels, and those levels are there. Now, what is meant by these levels? The levels, the bottom level 1 is basically the variation of the measurements. So there is a variation. Level 2 also there is a variation. Why there is a variation? Because I'm doing that 3 times, baseline, year 1 and year 2. I cannot expect that whatever my reading will be at the baseline will remain the same at year 1 and year 2 also, because subjects, these knee joints, those gap is changing. So it is expected that there will be a variation and so on. And subjects are of course different, and there will be subject variation also. But at this time, what I'm saying that the data that I described, if I put in the hierarchy, then these are the hierarchies: level 1, level 2, and level 3. And once we understand that hierarchy, that helps a lot to develop the model. Next slide, please. Okay, so these are the models, but we'll come back to this model. There is a very nice picture to understand the data. And go to the next slide, please. Yeah, go to the next one. Next one. Next one. We'll come back. Okay, this is the slide. Let's try to that figure, the before one. The one before it. Yes, this one. Okay. So let's try to understand the data. So these are the data plotted basically. Now, as I mentioned, there are 3 raters. One is a computer, and then human rater 1, human rater 2, and rater 3 is basically the computer. Those colors, the green one is for rater 3, the blue one is for rater 2, and the brown one is for, the brown one is for rater 2, and the blue one is for rater 1. Now we can see that, let's look at the brown one. There are 3 brown curves. There are 3 brown curves. The reason is that there are, okay, and each brown curve or the brown trend or line, there are 3 that dots are there. The bullets are there. Those are the measures. Baseline on the y-axis, middle one is year 1, and the end dot, that means that bubble, whatever we call, is year 2. So we have 3 measures. And if you look at the brown, there are 3 brown curves. The very first one is the first measure. The very last one is the second measure. At every time point, we are measuring twice. We are evaluating, we are rating the subject. All these graphs is only for one subject. There are 3 raters and there are twice. So brown dots, the first dots on the brown, little on the top of 2.5 and little below 1.5. Those dots are the 2 measures at the baseline. Similarly, the top graph and the very bottom graph of the brown at the middle, those are the points from the year 1, and the last dot of the brown and the last dot of the brown curve at the bottom from year 3, from year 2. Now, why is the bold brown at the middle? That is basically the averaging of the top and bottom curve. And every color, you see, there will be 3 colors. For every color, there will be 3 curves or 3 graphs, but the middle one will be the bold graph. And that bold graph is basically the averaging of the other 2. So we'd like to see if we have taken 2 measures at every time point, but if we have averaged, then what is there? And we can see. Now, remember, it is the same subject. The subject is not changing. But look at the 3 bold curves. The top one, the top bold with the cross sign, which is green, is the average coming from rater 3. The middle bold graph or the bold line is the rater 1, and the brown bold line is the rater 2. And they are far away from each other. For a perfect agreement, those three graphs, the bold graphs, should be one on the top of the others. But here, that is not the case. That means the raters are not agreeing with each other. And that's why we see the deviation of those graphs. And we have to bring all these concepts in the modeling. So Monimal, please go 2 slides up.
Just
2 slides up. Probably he's trying again to get back.
just a moment.
So the technical problem is there. Anyway, so let's try to, when we'll be getting back the connection, I can explain going through the slides, but let me try to bring the slide, try to explain the model. What is the model? So every model has some measurement, what is called the outcome measurement. Here is the width, what is will be denoted by X, Y. Then what is happening here? What is happening here is that I have hierarchy. Now I have to bring the hierarchy. The first hierarchy is the repeated observations at the same time. Thus, that is the baseline, what is level 1. The middle hierarchy is and there is a variation. As soon as you repeat the observations at the slide, the rater is measuring multiple times, and every time he'll be giving a measurement, and don't think that he'll be giving the same number. Rather, he'll be evaluating and giving a number. So there will be a variation, and that variation is basically within subject variation. And this within subject variation will be continuing at each time point. And then the subject variation. From one subject to the other subject, of course, these subjects are very different. So there will be a variation. And the rater variation, of course, is there. Even the subjects are the same. So what the raters are measuring, that is important. But raters are measuring basically the X-rays, and that is a variation. So we have to incorporate all those things, and as a result, in order to incorporate all those things, so something will be fixed. As we saw the lines, that is not a perfect line, straight line, but if we measure the straight line, so what kind of variation is there, and so on. So something will be fixed, and all other things will be varying. And because of that varying, so when we are getting a line for a subject and for many other stuff, that line will be changing, will be varying, and these variations will be using some random effects to measure the variation. But we don't know the values of those random numbers. We'll have some kind of assumptions on the random effects, mostly normal distribution, and then we'll be estimating all the parameters using mixed effects longitudinal design. But here is a little bit more problematic, because Generally, in mixed effects longitudinal design, at every time point, there is only one observation from a subject, but here we have multiple observations, 2 observations. But when we are writing down the model, we'll simply assume that there are multiple observations at the same time. And also, there are multiple X-rays from a single subject at different time points. So we have to incorporate those variations. And the model actually incorporating those, and then use some kind of software or write down the program. Probably she used R, she developed R programming, or maybe SAS to estimate the parameters. Okay, once we have estimated parameters, so that will be the model parameters as well as the variance components of the model after using the software. Now we have to bring those parameters to measure the agreement for our problem, which is the main thing, the agreement.
সরি ডিয়ার ভিউয়ার্স, আসলে আজকে একটু কেন জানি বারবার প্রবলেম করছে নেটে, আমি বারবার ডিসকানেক্টেড হয়ে যাচ্ছি। আমি চেষ্টা করছি স্লাইডটা আবার। স্যার, আমি আপনার ওখান থেকে স্লাইডটা একটু আপনি ওপেন করেন যদি।
তা পারবো।
ওখান থেকে স্যার স্লাইডটা ওপেন করেন, আমি হচ্ছে আপনাকে
করছি।
স্যার আপনি স্লাইডে যে স্লাইডে যেতে চান সেই স্লাইডে চলে যান সরাসরি, তাহলে হবে। হ্যাঁ, এই যে স্যার, আপনি স্যার এখান থেকে স্ক্রল করে নিচে যেতে পারবেন।
ও আচ্ছা, তোমরা কি দেখতে পাচ্ছ?
জি জি জি, হ্যাঁ হ্যাঁ স্যার, সবাই দেখতে পাচ্ছে।
ও তাহলে এতক্ষণ ধরে আমরা কি করছিলাম? হ্যাঁ হ্যাঁ, যাচ্ছি। হ্যাঁ, ভেরি গুড।
স্যার কন্টিনিউ করতে পারেন এখন।
হ্যাঁ হ্যাঁ, কন্টিনিউ, অবভিয়াসলি। এখন তো আমার হাতে, তাই না?
জি স্যার, জি স্যার।
ওকে, অনেকগুলো স্লাইডের মধ্যে বাদ দিয়ে দেব, কারণ আমাদের সময় তো নেই।
হ্যাঁ স্যার, 1 ঘন্টা হয়েছে, 1 ঘন্টা 15 মিনিট।
হ্যাঁ, আমি I'll go through this মডেলটা।
ওকে ওকে স্যার।
Okay, so these are the models. So this is the model in the multivariate setup, where beta x, as you can see, is the fixed parameter that is measuring basically the trend of the rater x, and vx and ux, something is measuring for the variation of the within and between. Those are the things. Every parameter has its own interpretation. As I said, if you look at here, clearly we got the second and the third level random effects to incorporate the variation of these levels, and is simply the error term. So lots of assumptions are there before we implement the model or estimate the model. Lots of assumptions are there, and all those assumptions should be reasonable. Otherwise, making just assumptions should not make any sense. So it took a long time to make these assumptions, but eventually it's fine. And you already saw that one, and that matrix model, if we put right in the scalar sense, then this would be the model, and every model has its own interpretation. Basically, we are trying to combine the rater x and y here together, and that once we have done, then this is the CCC in the matrix notation. So we have the covariance xy in the scalar form, then the variance x and w is another rater, say, then variance of w, variance of x, and the mean difference. This is in the scalar data, but for this vector data, when the matrix is coming into picture, the covariance matrix, and so on. So the generalization of this first expression in the matrix notation, one generalization at least, is this one. And we have to make sure that this expression is giving the value 1 or -1, at least 1, for the perfect matching, and so on, and 0 and so on. So we have done a huge simulation study, and that took a long time to estimate parameters. And you can see that these are the two values of the betas, these fixed parameters, 4 and 3.9, 4 and 3.98, -2, and so on and so on. At least we are happy with the simulation. And for perfect thing, we got 0.98, 98, 98. This is the intra. Intra means within the rater, and within rater, and so on. And CCC again, another set of simulation. It goes on like that. We have displayed the data, how the data 2 by 2 will look like, and so on and so on. Then we computed the intra CCC for rater 1, rater 2, and rater 3. It means that how good rater 1, I'm not comparing with any other rater, just only rater 1. He had the opportunity to evaluate or to rate twice, and is he agreeing with himself? That means 0.91, very good agreement. The rater 2, 0.87, well, good. And rater 3.84, not that bad. But rater 1 at least agreeing himself. Then again, now interrater. Interrater, we see that that means between two raters, 0.69, 0.62, not that great. Not that great. For two-level model. For two-level model means that we are not taking care of the repeated observations, just we took the average. But when we are using the 3-level, the hierarchy, we are doing better. Look at here. These are the simulation results. When it was the CCC, the agreement was 0.69 using a 2-level model. It has become 0.81, which is far better. And when it was 0.62, it went up to 0.76. So this is the payment for the hierarchy. Hierarchy means 3-level model, more complex, more time it takes to estimate parameters, and complexity we are addressing. As a result, we are getting better CCC also. So this data, as I said, there are more than 300 subjects in the study, but we got only 29 complete data. 29 complete data means lots of missing values. Then how to impute the missing values, we have discussed a lot, but that is not at this point my interest, so I can skip those, all the missing value techniques, how to incorporate and so on. I am just skipping those, but we took care of that in our study, in our simulation study as well as that. Okay. So once you know the model and once you know the assumptions, then, and we have the CCC, then we can compute the CCC, and I already showed what are the values of the CCC. Basically, it is 0.76, 0.81, something like that. Now, what is the meaning of those things? The CCC 0.8 or CCC 0.91, or is there any gold standard? When there is a gold standard, I compare those and I can say that this is good, that is bad, and so on. But absolutely, there is no gold standard for this kind of study. And then we are confused a little bit, even if we have a number of CCC, but what is it, a really good number or bad number? I mean, if it is close to 9.95, 99, obviously that's very good. And if it is close to, say, 0.3, 0.2, 0.1, that is really bad. But other than that, 0.76, say, for example, Is it a good agreement or bad agreement? I don't know, and nobody knows. So is that hypothesis testing? If you want to draw any inference, you know that whenever we are testing a hypothesis, there should be a null value. So what should be the null value? If there are gold standard, we could have used that, but there is nothing like that. So we don't know what should be the null value. And when we don't have the null value, how good it is for hypothesis testing, going through that approach, I don't think that that is that much meaningful. So instead, we are trying to give the confidence interval for the CCC parameter theta, as you can see here. The CCC parameter is theta. We are trying to give an interpretation of that, in terms of confidence interval. If the confidence interval, suppose it is say 0.50 to 0.69, then we can say that, well, not that bad. On the other hand, if the confidence interval is say 0.77 to 0.93, then we can see that, yeah, not bad at all. So that's the motivation for computing the confidence interval for the CCC. And the confidence interval, on the other hand, the coverage probability should be also very large. Otherwise, who will believe in my confidence interval? So the method that we used is the generalized confidence interval. It's a kind of little bit touch of the Bayesian, probably introduced by Fisher long back under the name fiducial. But we'll be calling it generalized confidence interval. So what, like Bayesian, they are using the data as well as the assumption on the parameters, and here is also. So those covariance matrices, S22 is the lower diagonal, S11 is the upper diagonal, and this is the kind of given thing. So we basically use that concept, the Wishart distribution, its properties, and the generalized interval confidence, and so on. And ultimately, we constructed a pivot, which is a kind of test statistic under hypothesis testing, but here is a pivot. And this pivot is basically measuring a kind of CCC. So what we'll be doing, we'll be simulation of the data, as well as we'll be taking the help of our original data. So the two things are going together. Once we have computed the data, that Wishart matrix, all those things that we need, as well as we are drawing the distribution, we are drawing some distribution from known distributions like chi-square here and here. You can see all those things. We'll be drawing from normal chi-square and chi-square.
Completing our second semester MSc in statistics.
And then we are developing the pivot statistic T, and which is a kind of measure for CCC. So we'd like to see, we are generating data, as I said, many times from the chi-square and normal, independent, and we are using the data also and constructing 10,000 times we have done that, and then using the histogram, constructing the alpha by 20th percentile, both left and right, to get the interval. Okay, so here is the result. So the confidence interval based on the generalized confidence interval estimated for CCC is like that. CCC estimated value from the data 0.9388, rater 1 and computer 0.8662, and rater 2 and computer 0.8712. So we see that rater 1 and 2 are the human raters, basically radiologists or the doctors. Their agreement is very good, actually, 0.94, close to, very good agreement. On the other hand, rater 1 and computer, it has dropped down to 0.86 or 87. That means if we totally depend on computer, and eventually in future, probably that is the future, means that all the human ratings will be out, and the devices will be there. Then we see that the agreement is not that much, especially when we know that the human raters far better agreement. So what should we do? The confidence interval, on the other hand, if you see, based on this generalized technique, is that 0.86 to 96, which is very good, and rater 1 and computer, which is not that bad because the lower value is 0.73, and rater 2 and computer is not also that great, the lower value is 0.75. The technique that we have developed in this work is how much we do have the coverage probability. Coverage probability we should expect 95% because that is the confidence interval. We see that the coverage probability is very good, very close to 95%, very close to 95%. So the methodology that we have developed, we have no question because it gives very high coverage probability. But when we are comparing the rater 1, rater 2 versus any other two raters, we see that the computer is not giving us that great values. So one conclusion is that besides the estimation and giving the value of CCC, we are going beyond that, giving the confidence interval value in order to understand the problem better, what is going on. And we see that rater 1 and rater 2 are agreeing very good, but not with the computers. Both the raters are falling behind. Not unfortunately, this part, generalized confidence interval, is being developed in this dissertation or the work for the only one measurement, not taking care of the longitudinal and so on and so on. The reason is that we have not developed that methodology yet, what we are doing right now. The whole dissertation derived 2 papers out of that. The confidence interval one got published just yesterday, the hard copy in Statistics in Medicine, and the before one, which is the modeling one, it is under revision by another widely journal, Bioinformatics, something like that, not Bioinformatics, some journal that is under revision. So this is a more or less thing that what is the contribution of this dissertation or work? The contribution is that we are dealing with much more complex continuous data and then developing the model, estimating the CCC and so on. And on the top of that, we are giving another inferential approach based on the generalized confidence interval technique and giving the confidence interval also. Now, this is the complexity of the data. If the data are very simple, then we could have Lean's definition itself or the Lean's measure itself. We don't need this kind of stuff. But you know, medical data are not that simple. Medical data are always very complex. And we, the biostatisticians, should address the complexity when we are analyzing those kind of data. And this is just an attempt towards that. Now, I think we can go back. This is all of my talk. So thank you again. Now, questions, if you have any question, how to do the questioning part. And Munimul, please help me going back.
Thank you, sir, for your nice presentation. Very interesting presentation,
Most
actually.
of the time.
But we have some internet problem as well as my laptop problem, and it is interrupted several times. I am sorry for that. স্যার আসলে খুবই ভালো একটা প্রেজেন্টেশন, কিন্তু আমি জানি না যে আমাদের ছেলেমেয়েরা কতটুকু আসলে কনসেন্ট্রেট করতে পেরেছে, কারণ বারবার ইন্টারাপ্টেড হয়েছে।
ওরা কি এর পরে দেখতে পাবে
আমাদের সাথে?
ওরা কি এটা পরে
দেখতে পাবে স্যার? এটা হ্যাঁ দেখতে পাবে স্যার,
তাহলে ওরা
পরে দেখতে পাবে। হ্যাঁ, এটা হচ্ছে স্যার হচ্ছে আপনার আমার ফেসবুক পেজে সবসময় থেকে যাবে। এরা যে কোনো সময় এই রেকর্ডিংটা দেখতে পাবে। এবং হচ্ছে এগুলো আমি ভিউয়ার্স আপনাদের জন্য আরেকটি ইনফরমেশন দেই, এই সবগুলো ভিডিওই আমরা ইউটিউবে আপলোড করে দিব আগামী
আবার চলে গেল ওর ইন্টারনেট কানেকশন।
আপনারা ইউটিউব থেকেও ভিডিওগুলো দেখে নিতে পারবেন। আমি হচ্ছে বেশ কয়েকজন এখানে কোশ্চেন করেছে, আমি তার মধ্যে বায়েজিদ এবং রশিদুল দুইজনকে অনুরোধ করব তোমরা যে লিঙ্কটি দেওয়া আছে আমার কমেন্টে, সেই কমেন্টের মাধ্যমে আমাদের সাথে যুক্ত হতে পারো এবং সরাসরি স্যারের সাথে প্রশ্নগুলি করতে পারো। সেই সাথে আমাদের সাথে আরো দুইজন স্যারের বন্ধু উপস্থিত আছেন, একজন যাই কোনো কারণে হয়তো ডিসকানেক্ট হয়ে গেল, ডক্টর আব্দুর রশিদ। আপনার যদি কোনো কোশ্চেন থাকে তাহলে আমরা সেই কোশ্চেনটি নিতে পারি। উনি হচ্ছে আমাদের আজকের প্রেজেন্টারের আর কি খুব কাছের একজন বন্ধু, সেই কারণে উনি সরাসরি এখানে যুক্ত হয়েছেন। তো আপনার যদি প্রশ্ন থাকে আপনিও সরাসরি প্রশ্নটি করতে পারেন। এবং ডক্টর কলিমুল্লাহ স্যার, আপনি ডিসকানেক্টেড হয়ে গেছেন, আপনি যদি আবার রিকানেক্ট হতে পারেন আপনাকেও আমরা আপনার প্রশ্নটা নিতে পারি। তো আমি বায়েজিদ এবং রশিদুলকে অনুরোধ করছি কোশ্চেন করার জন্য, এবং এখানে জয়েন করি কোশ্চেনটি করবে আর কি। তার আগে বলি স্যার হচ্ছে যে আমাদের সাথে বেশ কয়েকজন শিক্ষক কমেন্ট করেছেন, আমাদের ডিপার্টমেন্ট শিক্ষক যেমন আছেন, আমেরিকা থেকে মীর মাসুম আলী স্যার কমেন্ট করেছেন, ইন্ডিয়া থেকে সুমন চক্রবর্তী কমেন্ট করেছেন, এরকম ভাবে অস্ট্রেলিয়া থেকে কমেন্ট করেছে, প্রশ্ন আছে অস্ট্রেলিয়া থেকে। তো আমি সেই প্রশ্নগুলি দিব, আমি দেখি তারা জয়েন করে। তার আগে ডক্টর আব্দুর রশিদ স্যার, আপনার যদি কোনো প্রশ্ন থাকে বা কমেন্ট থাকে আপনি সংক্ষেপে বলবেন একদম। আপনার মাইকটা আনমিউট করে নিয়ে বলবেন।
আনমিউট। ডক্টর রশিদ আমার বন্ধু, but he's a biostatistician also.
কমেন্ট থাকে আপনি সংক্ষেপে বলবেন। আপনার মাইকটা আনমিউট করে নিয়ে বলবেন।
ডক্টর রশিদ আমার বন্ধু, he's a biostatistician also.
কমেন্ট থাকে আপনি সংক্ষেপে বলবেন। আপনার মাইকটা আনমিউট করে নিয়ে বলবেন।
Unmute. Unmute.
আব্দুর রশিদ স্যার, আপনি কি প্রশ্ন? হ্যাঁ জি বলেন।
না, আমার এখন কোনো প্রশ্ন নেই, পরে আমি তাদের সঙ্গে আলাপ করে আমি
ওকে
জেনে নিব।
আচ্ছা, থ্যাংক ইউ স্যার। আমাদের সাথে যোগদান করেছে আমাদের ফোর্থ ইয়ারের স্টুডেন্ট, ওর কোশ্চেনটি স্যার আমি স্ক্রিনে দিচ্ছি। ওর 3টি কোশ্চেন আছে। বায়েজিদ স্যার, স্যার আমাদের ডিপার্টমেন্টে এর আগেও এসেছেন এবং স্যার আমাদের ডিপার্টমেন্টের হচ্ছে একজন বন্ধু আর কি বলতে পারি আমাদের। যেমন বিমল স্যার সবসময় আমাদের ডিপার্টমেন্টের জন্য আমরা যা আবদার করি সেটা উনি পূরণ করেন। বিকাশ স্যার তো আসলে বলার অপেক্ষা রাখে না যে তিনি আমাদের ডিপার্টমেন্টের জন্য কি, এবং আমাদের ডিপার্টমেন্টের এই পর্যায়ে আসার জন্য বিকাশ স্যার এবং বিমল স্যারের অবদান আসলে অনেক বেশি। বিকাশ, স্পেশালি বিকাশ স্যার তো সার্বক্ষণিক ভাবে আমাদের সাথে যোগাযোগ রাখেন এবং ডিপার্টমেন্টের সাথে মনে হয় দিনে 10 থেকে 12টি মেল আদান প্রদান হয় বিকাশ এবং বিমল স্যার। আমাদের দুর্ভাগ্য যে বিমল স্যার কোনোদিনই আমাদের ডিপার্টমেন্টে আসেননি, তবে ভবিষ্যতে উনি আসবেন সেটা বলেছেন এবং আমরা সেই অপেক্ষায় আছি কবে উনি আসেন আর কি। তো আমি বায়েজিদ তোমার কোশ্চেন, 1 নম্বর কোশ্চেনটি স্ক্রিনে দিচ্ছি, তুমি কোশ্চেনটি স্যারের সাথে ইন্ট্রোডিউস হয়ে কোশ্চেনটি করো। দুলাল স্যার, আপনি কোশ্চেনটি মনে হয় স্ক্রিনে দেখতে পাচ্ছেন।
না, হ্যাঁ, আই থিংক এটা খুব ভালো প্রশ্ন 1 নম্বর। আর 2 নম্বর হচ্ছে যে যখন আমি লংজিটিউডিনাল ডেটা নিয়ে প্রথম কাজ করছিলাম তখন আমার এক্স্যাক্টলি একই কোশ্চেন ছিল যে টাইম সিরিজটা তো আমরা পড়েছি, আমরা বিএসসি এমএসসি সবসময় পড়েছি, পিএইচডি করার সময় টাইম সিরিজ পড়েছি, তাহলে হঠাৎ টাইম সিরিজের ডেটাগুলোকে একটা লংজিটিউডিনাল ডেটা বলার উদ্দেশ্যটা কি, আর সেটা কি আমরা টাইম সিরিজ বলতে পারি না? উত্তর হচ্ছে যে পার্থক্য আছে, অনেকটাই পার্থক্য আছে। টাইম সিরিজটা যখন ডেটা টাইম রিলেটেড জিনিসগুলো যখন ঘটে যাচ্ছে, সেটা এনভায়রনমেন্টাল হতে পারে, বৃষ্টিপাত হতে পারে বা এই টাইপের জিনিসগুলো, বিশেষ করে মার্কেটিং এ আমি একটা প্রোডাক্ট ছেড়েছি, এবার কতখানি বিক্রি হচ্ছে বা লোকগুলো কতখানি চাইছে, এন্ড ওভার দ্য টাইম আই এম মেজারিং করছি সেইটা। কিন্তু লংজিটিউডিনাল ডেটাটা অন দ্য আদার হ্যান্ড ইট হ্যাজ এ ডিফারেন্ট মোটিভেশন, পার্টিকুলারলি মোটিভেশনটা হচ্ছে মেডিকেল সায়েন্সে বা ক্লিনিক্যাল ট্রায়ালে। কোশ্চেনটা এরকম হচ্ছে যে আমি একটা কিছু এক্সপেরিমেন্ট করতে যাচ্ছি, আমি কোনো স্টাডি করতে যাচ্ছি, আমি স্টাডিটা ক্রস সেকশনাল করতে পারি, মানে আমার স্টাডি সাবজেক্ট আছে অ্যান্ড আই এম মেজারিং দ্য সাবজেক্ট অনলি ওয়ান টাইম। সেটা হতেই পারে, যেমন কোন একটা মেডিসিনের এফিকাসি কি আছে সেটা দেখতে পারি, কিন্তু বলেছে যে টেক দিস মেডিসিন ফর 2 months অর সে 1 month, তখন আমি করতে পারি যে একদম 1 month শেষ হয়ে গেল, তারপরে আমি শেষে গিয়ে মেজারমেন্টটা নিলাম in order to see how much it got improved from that medicine. কিন্তু এই কোশ্চেনটা তো খুব, একটা মাস তো অনেক সময় একটা রোগীর জন্য, and we'd like to see how much progress is there. So instead of taking the measurement at the very end point, I'm deciding to take measurements at every week, যে প্রোগ্রেসটা দেখতে চাইছি। তাহলে আমি আগেই ডিটারমিন করলাম যে আমি এই স্টাডিটা করব, আই উইল টেক দ্য মেজারমেন্ট এভরি উইক, and there will be baseline measurement after a week, after 2 weeks, after 3 weeks, and then 4th week there will be 5 measurements, something like that. So তখন এই স্টাডিটাকে বলবো আমি একটা লংজিটিউডিনাল। এটা কিন্তু অনেকটা প্রিডিটারমিন্ড হয়ে গেছে আমি কি করতে চাইছি। আমি একটা প্রোডাক্ট মার্কেটে ছেড়ে দিলাম, আমি ছেড়ে দিয়ে তারপর আমি দেখছি যে কি হচ্ছে, দাম উঠছে না বাড়ছে, স্টক মার্কেটে ওরকম হতে পারে, সেটা মার্কেটের ওপর ডিপেন্ড করছে, অ্যান্ড দোজ আর কোরিলেটেড, বিকজ আজ দাম বাড়লে কালকেও দাম বাড়তে পারে, বা কোনো একটা কারণে ক্র্যাশ করে গেছে মার্কেট, কালকে ওটা ফল করবে, সেটা ইটস ভেরি ডিফারেন্ট। But purpose here is extremely different here, very, very different. Purpose here is to see the progress, basically the systematic progress of the disease or the medicine, how much the efficacy is there. When those type of things are coming over time, then we are calling it a longitudinal design. And longitudinal design, of course, hierarchical design এর ভিতরে পড়ছে, because the measurement will be nested within the subject, but it is a longitudinal design. So এভাবে দেখা যেতে পারে। আরেকটা কোশ্চেন হচ্ছে যে সেটা মডেলিং এর ব্যাপার, যে আমি কি অ্যাসাম্পশনে মডেলটা করছি। দেখো, যখন একটা মার্কেটে যাচ্ছে তখন আমি স্টক মার্কেটে ইনভেস্ট করছি বা আমার প্রোডাক্ট কিরকম বিক্রি হচ্ছে, তখন এরকম আপ ডাউনটা ফর এভরি ডে ইজ ইম্পর্টেন্ট, বিকজ ইফ আই মিস দ্য ডে টু ডে, then after a week I am coming back and thinking that everything will be smooth, which is not the case, because it is always a kind of volatile thing. On the other hand, if you have a patient who is being, say, hospitalized, and you are going to see the patient every day, at least when my mother was in hospital, many days are very pathetic days, because the improvement doesn't go like that way. আজকে দেখছি আমার পেশেন্টকে বেশ ভালোই করছে, কালকে গিয়ে দেখলাম যে টোটালি অফ হয়ে গেছে, উঠতেই পারছে না, কথা বলতে পারছে না, তখন মনটা ভীষণ খারাপ হয়ে যায় যে তাহলে কি ডিটোরিয়েট করছে। সো কোশ্চেন ইজ নট দ্যাট হোয়াট দ্য পেশেন্ট ইজ ডুইং এভরি আওয়ার, but when the medication is being prescribed for a month, say, I would like to see what is the trend over a week. যদি উইকটা ভালো থাকে, ঠিক মতো যায়, then I am happy. So I'll be very much displeased, worried, and tensed if I start observing that patient every hour or every day, because medical ব্যাপারটা, হেলথ ব্যাপারটা কখনো ওইরকম ভাবে এগোয় না, এরকম ভাবে এগোয় না, সবসময় এরকম ভাবে এগোয়, অ্যান্ড প্রত্যেকটা মোমেন্ট দেখাটা ঠিক না, ওভারঅল একটা ট্রেন্ড দেখা। তখন এটাকে আমি বলবো একটা লংজিটিউডিনাল ডিজাইন, কারণ হচ্ছে যে সেভাবেই এটা প্ল্যান করা হয়েছে যে উইল বি অবজার্ভিং দ্য পেশেন্টস or whatever it is, the subjects, like that way. So this is a kind of difference. Okay, anyway, so next question please. Oh, cross-sectional data. Cross-sectional মানে basically only one time data. Longitudinal multiple times over the time করছি. What are the difference? Yeah, so I explained. The next question please. If two raters are dependent, okay, here the first question is that these raters are independent. So dependent হলে ওই রেটারটাকে ছেড়ে দিয়ে আরেকটা রেটার নাও যে independent হবে। Cohen's kappa, I should say that in the whole study, or at least the assumption is that those are তাহলে আবার তাদের dependency, or at least that assumption is not in my talk. এমনি যথেষ্ট কমপ্লিকেটেড মডেল, তারপর একটা অ্যাসাম্পশন মানেই হচ্ছে তার উপর প্যারামিটার আনতে হবে, সেটাকে এস্টিমেট করতে হবে, সেটা ইনফ্লুয়েন্স করবে, সে সমস্তগুলো। আচ্ছা, দেন if data set is skewed, then Cohen kappa. Okay, see, I'm not using Cohen kappa. First of all, Cohen kappa has lots of problem. Even if you go to that, and I gave you an example of the problem of Cohen kappa. Even if you don't have this kind of problems, still Cohen kappa একটা ছোট্ট example দিয়ে বলে দিয়েছিলাম। So question is that data set skewed করার জন্য যদি নর্মালিটি, কোহেন কাপ্পা তো আর skewed ফিউড আনছে না, ওটা রেটিং এর উপরে বেস করে গেছে। But this question is very much appropriate to me because I have assumed the normality in my whole model. So if the data is skewed, can I use the normality? The answer is no. Then we have to figure out what kind of skewedness is there. I'll try to transform, which I have done many times in many of my research. Right skewed এর জন্য log transformation করেছি, cube root transformation করেছি, square root transformation করেছি, হেনো করেছি, তেনো করেছি। So it's better to go through some kind of transformation to bring it to the normal distribution. Why do normal distribution? Normal distribution হলে ব্যাপারগুলো স্টাডি করা সহজ হয়, কিন্তু তা না হলে অন্য প্রপার্টি ইউজ করতে হবে, লার্জ স্যাম্পল প্রপার্টি ইউজ করতে হবে, তারপরে ওটাতে কিছু একটা অনেকগুলো টেকনিকই আছে, স্লাস্কিজ রেজাল্ট আনতে হবে, এই সবগুলো আছে, তখন হিউজ ডেটা ডিপেন্ডেন্ট হয়ে যাবে, মানে লার্জ স্যাম্পল ডিপেন্ডেন্ট হয়ে যাবে। সেই জন্য ইটস বেটার টু ট্রান্সফর্ম দ্য ভ্যারিয়েবলস টু মেক শিওর দ্যাট more or less you are getting normal distribution, and probably we have also done that Fisher-Z transformation টাইপের কিছু করে টরে ওই সবগুলো করা হয়েছে। So I would recommend that do those basic things first before jumping to the model, because model assumptions are very much strict. Next person. Yeah, as many of my papers appeared in Technometrics, where I discussed these type of questions, means that what should we do for skewness data, and in connection to groundwater or water problem. So, okay, Rashidul Alam Mahmood, thank you very much, Professor, for your excellent presentation. The response rate was very poor in this trial. Response rate means what? 29 completed follow-up periods. In terms of precision, what is the scientific explanation of the? Okay, first of all, when I was dealing with the data, I could not do anything with that. I mean, whatever the data I had, I have to depend on that. But if you ask me to incorporate this problem or to try to solve a problem, then my answer is the following. I am involved in many clinical trials, many clinical trials, at least 5 of those, maybe 10 right now. So this issue comes again and again. What should we do to minimize the withdrawal rates, dropout rates, attrition? How to minimize those things means that we'll not be losing that many subjects and so on. Now, there are many techniques we are using at this moment also. One is that whenever we don't see the subject, call the subject. Means that call them, phone, and try to understand the reason for the missing them, why the subject did not appear. If needed, we send people. Somebody said that, oh, I don't have any ride today. That means his car is not working or somebody is not giving him ride to come to the hospital. Then we send people to bring the patient. then said that, oh, I was off today, means health-wise I am not doing good today. Okay, then the same caller will be calling tomorrow, day after tomorrow, and whenever the patient is ready, then taking the measurements. So these are different approaches we do have to minimize the non-response. Try to get as much as possible. Then, if we can't do that, then we try to understand the reason for missingness. For what reason the subject or the observation is missing. And to understand that reason basically helps a lot to impute the data. There are many, many techniques we use. I have one publication with a sociologist, at least 4 or 5 different types of imputation technique we have used over there to impute the values, missing values. So that is another technique. Now here I said that 28 participants completed the study. I was not involved in this study from the very beginning. She was, my student was, not me. Then question is that, so how to increase the efficiency and so on. We used multiple imputation techniques to use the results, and in the dissertation that I shared, we have discussed those things in the dissertation. Probably I have not shared, but in her slides we have, and if you are more interested, I can share some other papers. But there is no quick solution to this problem.
Okay, thank you, sir. Sir.
Yes. Next.
Next, sir, another question from Rasidul Islam Mahmood. What are the biggest practical hurdles to conducting longitudinal research? What are the ways to overcome them?
Okay, longitudinal design, yeah, first of all, it is more expensive. There is no doubt, because you are observing multiple times. Retaining the subject is another hurdle, but more financial support we decide at the very beginning, that how much it will require to complete the study, and accordingly our budget is set up, or we ask money to from the government. So that is one. The retaining the subject is extremely important, and several measures I said that how to get back those subjects, or if they are missing, then how to call them or send people and so on. The data complexity is of course there, and we should know the cause of missingness, and once you get that, many times the analysis becomes very complex, especially for neuroimaging data. It is an extremely complex thing, and many times our laptops or the desktop don't permit us to do the analysis. We need many sophisticated, powerful computers. So these are the problems, and the problems are there. But financially, before starting the study, we need a budget, and unless the budget permits, we cannot simply start even the study. And another thing is the longitudinal, is the adverse effect, which is the most important thing. The study is going on, the medicine is given to the patient, and the patient is now dying. Immediately you have to stop the study, and then a committee, what is called Data Safety Monitoring Board, that board will be there. They will be discussing the case, what next we can do, not for a study, but to save the life of the patient. That is the most important thing. Another hurdle, and repeatedly it may come, and then that is a real problem. So hurdles are there, but in the protocols we also write. Recently, I'm involved in a protocol of NVA study. So protocol means it's basically a book where we write down all the unforeseen occurrences, what can happen, and if it happens, then what should we do? So that will take a few hours to discuss the clinical trials problems. Okay, next one, please.
ওকে, ধন্যবাদ স্যার। কোশ্চেন আমরা নিব না, আর যে কোশ্চেন ছিল মোহাম্মদ ফাহিমের একটি কোশ্চেন ছিল, ওই কোশ্চেনের উত্তর অলরেডি সে পেয়ে গেছে। শ্রোতা বন্ধুরা, দর্শক বন্ধুরা, আপনারা যারা এই প্রোগ্রামটি লম্বা সময় ধরে দেখলেন, বাংলাদেশে সহ সারা পৃথিবীতে করোনা আবার ভয়াল গ্রাস করছে আসলে আমাদেরকে, এবং বাংলাদেশে আজকেও বেশ অনেকগুলো করোনা ডিটেক্ট হয়েছে। সুতরাং আপনারা সবাই সতর্কতা অবলম্বন করবেন, স্বাস্থ্যবিধি মেনে চলবেন, এবং আমরা সবাই যাতে সুস্থ থাকি সেই জন্য আমরা সবাই সবার জন্য দোয়া করব। এবং সেই সাথে আজকে যে লেকচারটি আপনাদের সামনে উপস্থাপিত হলো ডক্টর দুলাল কে ভৌমিকের মাধ্যমে, আপনারা যদি এর মাধ্যমে সামান্যতম উপকৃত হন তাহলে আমাদের এই পরিশ্রমটি সার্থক হবে। এবং স্যার দীর্ঘ সময় ধরে যে লেকচারটি দিলেন, স্যারকে অনেক ধন্যবাদ, এবং আমরা ভবিষ্যতে আবার আপনার কাছ থেকে শুনতে চাইবো। সেই সাথে আমি বিমল স্যার, আপনি যদি খুব সংক্ষেপে কিছু বলতে চান তাহলে আমরা সেটা শুনবো, তারপর আমরা হয়তো আজকের প্রোগ্রামটি শেষ করব।
ওকে মনিমুল, থ্যাংক ইউ। তুমি আমাদের অন বিহাফ অফ ইউর ডিপার্টমেন্ট তুমি এত সুন্দর অর্গানাইজ করছো, এবং ফ্রম টাইম টু টাইম ইন্টারন্যাশনাল স্পিকার্সদের নিয়ে আসছো, নট নেসেসারি ফ্রম ইউএস। ইউ শুড ট্রাই টু গেট স্পিকার্স ফ্রম অস্ট্রেলিয়া, ইউরোপ, আদার কান্ট্রিজ। তোমাদের যেগুলো টপিক গুলো তোমাদের মনে হয় ভালো আর কি, হ্যাঁ, সেগুলো তোমাদের রেলিভেন্ট তোমাদের স্টুডেন্ট পপুলেশন জন্য, ফ্যাকাল্টির জন্য। সো থ্যাংক ইউ ফর অ্যারেঞ্জিং দ্যাট। থ্যাংক ইউ, ভেরি নাইস প্রেজেন্টেশন। তুমি আমাদের ডিপার্টমেন্টকে খুব হেল্প করলে।
ধন্যবাদ স্যার।
মনিমুল, আমার তো খুব ভালো লাগছে, আর একটু খারাপ লাগছে যে আমি রাজশাহীতে তোমাদের ডিপার্টমেন্টে প্রেজেন্ট থেকে এই টকটা দিতে পারছি না, বাট আছি। যখনই একটু কমবে তখন তো আমার তো পাবনাতেই বাড়ি, পাবনাতে তো যাই এবং রাজশাহীতেও যাব, নিশ্চয়ই যাব রাজশাহীতে। তোমরা তো এখন বন্ধু।
স্যার অবশ্যই মোস্ট ওয়েলকাম স্যার, যে কোনো সময়। আসলে আমাদের বাংলাদেশে গত এক সপ্তাহ থেকে ইন্টারনেটটা বেশ স্লো এবং বারবার ডিস্টার্ব করছে, এবং আজকেও খুবই ডিস্টার্ব করছে, এবং আজ রাত থেকে আগামী কালকে পর্যন্ত
বাংলাদেশের খবর তো প্রতি ঘন্টাতেই পাচ্ছি, কি হচ্ছে না হচ্ছে সেটা জানছি। তার থেকেও একটা বাজে খবর হচ্ছে করোনাটা আবার উঠছে। এটা তো খারাপই,
করোনাটা অনেক বাড়ছে। হ্যাঁ, তবে ইন্টারনেট প্রবলেমের জন্য আমাকে অনেকে পার্সোনালি ফোন করেছিল যে যারা ইন্টারনেট প্রবলেমের জন্য আজকে ফেসবুকই ওপেন করতে পারছে না, এবং এই প্রবলেমটা আসলে বেশ কয়েকদিন থেকে বাংলাদেশে ফেস করছে সবাই, যে ফেসবুকটা ঠিকমতো ওপেন হচ্ছে না। এবং ইন্ডিয়াতেও কালকে আমি কথা বলছিলাম একজন প্রফেসরের সাথে, তিনিও বলছিলেন যে ইন্ডিয়াতেও গত কয়েকদিন আসলে নেটের একটু প্রবলেম ছিল। তো আমাদের আজকেও প্রোগ্রামটি বারবার হ্যাম্পার হয়েছে নেটের জন্য, সেই সাথে বিভিন্ন কারণে আজকে প্রোগ্রামটি হ্যাম্পার হয়েছে। আপনারা ক্ষমা সুন্দর দৃষ্টিতে দেখবেন। এই রেকর্ডিংটি আপনারা আমার ফেসবুক পেজে সবসময় পাবেন, সেই সাথে এটা ইউটিউব চ্যানেলেও, আমার যে ইউটিউব চ্যানেলটি চালু হতে যাচ্ছে মোহাম্মদ মনিমুল হক নামে, সেই চ্যানেলেও আপনারা এটি সবসময় দেখতে পাবেন ইউটিউবে, এবং আপনারা এখান থেকে নিজেদেরকে এনরিচ করতে পারবেন। তো আমি আরো একবার ধন্যবাদ জানাতে চাই ডক্টর দুলাল কে ভৌমিক স্যার আপনাকে। স্যার আপনি যদি শেষ মুহূর্তে আর কিছু বলতে চান তাহলে সেটা বলতে পারেন, আমি এখন প্রোগ্রামটি শেষ করতে যাচ্ছি।
আচ্ছা, আমি দেখবো তোমাদের যদি আর কোনো কোশ্চেন থাকে প্লিজ আমাকে ইমেইল করে জানিও। হয়তো অনেকেরই আমার ইমেইল অ্যাড্রেসটা আছে, প্লাস আমার ওয়েব পেজেও দেখতে পারো, ইউনিভার্সিটি ওয়েব পেজ। আর মনিমুল, তোমাকে বিশেষ করে ধন্যবাদ। আমি তো তোমাদের ডিপার্টমেন্টে অনেককেই চিনি, তাদেরকে দেখতে পাচ্ছি না, একটু খারাপই লাগছে। আশা করি এর পরে দেখতে পাবো। আর
স্যার আসলে এই প্ল্যাটফর্মে তো আসলে সবাইকে যুক্ত করা সম্ভব হয় না, আর অনেকেই স্যার আছেন কমেন্ট করেছেন আর কি আপনার জন্য। সেটা দুলাল স্যার হচ্ছে কমেন্ট করেছেন, সাইদুল স্যার কমেন্ট করেছেন, আয়ুব আলী স্যার কমেন্ট করেছেন, আমাদের চেয়ারম্যান স্যারও শুভকামনা জানিয়েছেন। অনেকেই আছেন, আসলে অনেকে দেখেছেন আর কি, সবাই হয়তো কমেন্ট করেননি, কিন্তু আমাদের ডিপার্টমেন্টে অলমোস্ট সব টিচাররাই আর কি প্রোগ্রামটি দেখেছেন আর কি।
আচ্ছা, খুব ভালো, খুব ভালো।
ঠিক আছে স্যার, আমি তাহলে আজকের প্রোগ্রামটি শেষ করতে চাচ্ছি। শ্রোতা বন্ধুরা, আপনারা এই দীর্ঘ সময় আমাদের সাথে ছিলেন, এবং সেই সাথে ডক্টর আব্দুর রশিদ, আপনাকে অনেক ধন্যবাদ। প্রফেসর বিমল কে সিনহা, আপনাকে ধন্যবাদ। বাইজিদ, তোমাকেও ধন্যবাদ, তুমি আমাদের অল্প সময় আমাদের মাঝে ছিলে। এর মধ্যে ডক্টর কলিমুল্লাহ স্যার ছিলেন, উনিও এই মুহূর্তে ডিসকানেক্ট হয়ে গেছেন, আপনাকেও ধন্যবাদ এই প্রোগ্রামে যোগদান করার জন্য। সেই সাথে দেশে বিদেশে যারা এই প্রোগ্রামটি দেখেছেন আপনাদের সবাইকে ধন্যবাদ জানিয়ে, এবং আগামী এপিসোডটি আগামী 8ই এপ্রিল প্রফেসর রহমতুল্লাহ ইমনের একটি লেকচার প্রচারিত হবে। আপনাদের সেই প্রোগ্রামটি আগামী 8ই এপ্রিল রাত 8টায়, একই সময় আমরা প্রত্যেকদিন চেষ্টা করি একই সময় এই প্রোগ্রামটি করার জন্য, বৃহস্পতিবার রাত 8টায় আপনারা সেই প্রোগ্রামটি দেখবেন। সেই প্রোগ্রামটি দেখার আমন্ত্রণ জানিয়ে, এবং সেই সাথে করোনার সময় সতর্কতা অবলম্বন করে স্বাস্থ্যবিধি মেনে আপনারা চলবেন, সবাই সুস্থ থাকবেন, সেই প্রত্যাশা ব্যক্ত করে অনেক ধন্যবাদ। আজকের মতো এখানে শেষ করছি।